what is the inner core electron? We already know that group 14 elements have a general electronic configuration of Ns2Np2. This is the outermost electronic configuration. So why it is known as amphoteric in nature? Because these two elements, when they exist in a dioxide form, they can also behave like an acid as well as the base. So if you see that electronic configuration in the ground state and excited state, you can clearly understand that there is no involvement of the d orbital. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called some pBLOCK element. Under this unit, we have discussed about the chemical properties of group 13 and we have learned that what are the anomalous behavior of boron, and also we have learned about some of the important compounds of boron by understanding the borax, orthoboric acid and diborate. In all this compound, we have understood their properties as well as the method of preparation. In addition to that, we also learned about the structure of diborate and uses of the boron and its compound we have learned. Today, let us move on to the next topic of this unit by understanding with the group 14 elements in the periodic table, that is carbon family. Okay, and their electronic configuration we are going to understand, their physical and chemical property, and how does this group 14, which also reacted towards the air and reacted towards the water, we are going to understand, and also we are going to understand why carbon will be looks different from the other rest of the element by understanding the anomalous behavior, and also we are going to understand the allotropic forms of carbon. Okay, we'll see first with the carbon family or with the group 14 elements. So in the group 14 elements, it is generally known as what? Carbon family, because the first member itself is a carbon and it consists of one non-metal, that is a carbon, and the two metalloid, that is silicon as well as with a germanium. So the first one is a carbon, next is silicon, next is germanium, then tin, that is tin and lead. Tin and lead. So these are the group 14 elements. Which are those? You can see that first one is a non-metal and these two are the metalloids, and you can see that the tin and leads are nothing but metals. Okay, and the carbon family of the elements, they contain the atoms and they have a 4 electrons in their outermost shell. If you see that group 14 elements, in its outermost shell, generally it has 4 electrons. It has how many electrons? 4 electrons. Hence, it can belonging to the group 14 because the valency will be 4, because in its outermost shell, it consists of 4 electrons. And the carbon family elements tend to be fairly unreactive. The elements tend to form a covalent form, though the lead and tin forms a ionic compound. If you see that group 14 element, except the tin and lead, you know, all the other elements, they forms what? Covalent compounds by sharing its all the 4 electrons to the other elements. Okay, the best example is carbon. So what is the valency of the carbon? 4. Correct, no? So it is always bounded with the other rest of the element, thereby it will share all its 4 electrons to the other element and thereby it forms a 4 covalent bond. So except tin and lead, you know, all other elements, they forms a covalent bond. The tin and lead, it forms a ionic bond with the compounds. Okay, the carbon family elements are exist in a free nature as well as in the compounds form. Now let us see the electronic configurations of group 14. Okay, the valence electronic configuration of group 14 is Ns2Np2. So how many electrons will be there? There are 4 electrons will be there in its outermost shell. So we'll see with the group member. So first one is the carbon, the symbol is C, and the electronic configuration is helium 2s2 2p2. Next is silicon, it is represented as Si, and the electronic configurations will be neon 3:3p2. Similarly, we have germanium and it is represented as Ge, and electronic configurations will be argon 3d10, 4:2 and 4p2. Next is tin and it is represented as Sn, and the electronic configurations will be krypton 4d10, 5s2 and 5p2. If you see all these elements, the last electrons are entering to the which orbital? To the p orbital, hence they are known as what? P-block element. And also if you see the valence electronic configuration, in all these elements, it consists of 4 electrons in its valence shell, hence their oxidation state will be +4. Okay, so thereby it will share all its 4 electrons with the other element and forms what? Covalent bond except tin and lead. Next we have the trends in their periodic property. So already we have understood that the group 14 elements, they forms a covalent compounds by sharing its all the electron, the 4 electron with the other element. Correct, no? So the covalent radius increases from carbon to silicon, but the silicon to lead, a small increase in the radius will be observed. This is due to the completely filled d and f orbitals in the heavier member. So as we move down the group, the covalent nature will be increases from carbon to silicon. After that, there is a small increasing in our covalent radius will be observed, because we know that after the silicon, the remaining elements like a tin and lead, those elements, they forms a ionic bond with the other rest of the elements. Coming into the ionization enthalpy, the first ionization enthalpy of group 14 elements are higher than the corresponding members of group 40 due to the influence of the inner core effect. So what is the inner core electron? We already know that group 14 elements have a general electronic configuration of Ns2 and P2. This is the outermost electronic configuration. Due to those 4 electrons in its outermost shell, their first ionization energy will be higher as it is compared with the group 13. In general, we can say that ionization enthalpy will be decreases down the group. So it will be decreases down the group, and there is a small decreasing in ionization enthalpy from silicon to germanium, then to the tin. And the slight increasing in ionization enthalpy from tin to lead, this is due to the poor shielding of intervening d and f orbital, and there is an increase in size of the atom. What does it mean? So as we move along the period, what will happen? There is a increasing in ionization enthalpy will be observed. So as we see this group 14 elements, from tin to lead, there is a small increment will be there. After that, first if you see the ionization enthalpy from silicon to germanium, then to the tin, there is a slight increasing in ionization enthalpy will be observed due to the increasing in atomic number. But after the tin to the lead, there is a small decreasing in ionization enthalpy will be observed. This is due to the poor shielding of d and f orbitals. So this is very important to understand that why it is a slight decreasing in ionization enthalpy as we seen in case of tin to lead. Coming into the electronegativity of the carbon family elements are slightly more than the group 13 elements due to their smaller size. So as we know that the group 14 elements are also smaller in the size, and there is a slight improvement in the electron negativity will be observed as it is compared with the group 13, and electronegativity values of elements from silicon to the lead are almost same. If you see that the silicon as well as with the lead, the electronegativity values are one and the same. Next we have the physical properties of group 14 elements. So all the group 14 elements are solid, okay, and the carbon and silicon are non-metal as we have already understood that. The germanium is a metalloid, the tin and leads are the soft metal. So as we have understood that the first member is a carbon, next is silicon, germanium, then tin, then lead. Correct, no? The first two is generally non-metal. We say silicon and germanium together as a metalloids also. Okay. And next, tin and leads are the metals. And that too, it is soft. These are metalloid. And this is only the non-metal we can see. Okay. And the melting and boiling points of group 14 elements are much higher than that of the group 13. So, why it is very high? Because of the increase in atomic number. Next is chemical property. In this chemical property, we are going to understand the oxidation state of the group 14 elements. Generally, we have understood that in its outermost shell, it has 4 electrons. Is it right? It has 4 electrons. Thereby, it will share all its 4 electrons to form a bond with other compound. Either it does not gain the electron or either it does not lose its electron. Instead of this, it will share its all 4 electrons and forms a bond. But if you see the common oxidation state, we know that the common oxidation state is +4 because it's having a 4 electron in its outermost shell. In addition to this, we can also observe that the +2 oxidation state can also be observed. This is due to the NP2 shells. That is because of the p orbital which is going to be added up and it is retained its electrons. Since the sum of the first 4 ionization enthalpies are very high, the compounds in the +4 oxidation states are generally covalent in nature. If you see the higher members of group 14, the tendency to show the +2 oxidation state increases in the sequence of germanium, tin and lead. This is due to the inability of NS2 electrons in its valence shell. As we move down the group from carbon, silicon, germanium, then tin and lead, the +2 oxidation state will be completely become inert. What does it mean? The electrons which is there in the s orbitals, it does not involved in the bonding at all. As a result of this, the NS2 electrons are become completely inert and this shows the inert pair effect. Due to this, the +2 oxidation state, it will be increases as we move down the group. The +4 oxidation state will be decreases as we move down the group. Why it is decreases? If you count these 2 electrons, it will become +4. And as we move down the group, what will happen to the s orbital? It is completely become inert. So that the +4 oxidation state will be become what? Inert, or it will be decreases down the group, whereas the +2 oxidation state will be become increases as we move down the group. That is mainly because the electrons are being added up to the p orbital. Thereby, the +2 oxidation stability will be increases down the group as it is compared with the +4 oxidation state. This is due to the inert pair effect. Okay. Next, we have reactivity towards the oxygen. Let's see how does this group 14 elements can also react with the oxygen and forms the oxides. Okay. All the group 14 elements, when it is heated with an oxygen, they forms 2 types of oxide. One is monoxide, another one is dioxide, and it is generally represented as MO and MO2. Monoxide as MO, dioxide as MO2. And the silicon oxide exists at very high temperature. The oxides in the higher oxidation states of the elements are generally more acidic than those of the lower oxidation state. Whereas the dioxide, if you see, like carbon dioxide, silicon dioxide, whereas germanium oxides, they are the dioxide forms of what? Group 14. Whereas if you see the monoxide, like carbon monoxide, silicon oxide, germanium oxide, these are the monoxide forms of what? Group 14 elements. The dioxides such as carbon dioxide, silicon dioxide and germanium oxide are also acidic in nature, whereas if you see the lead oxide and tin oxide, these 2 elements, when they exist in dioxide form, they are known as amphoteric in nature. What does it mean? So, why it is known as amphoteric in nature? Because these 2 elements, when they exist in a dioxide form, they can also behave like an acid as well as the base. Hence, it is known as what? amphoteric in nature. Among the monoxide, carbon monoxide is a neutral, germanium oxide is acidic, whereas the tin oxide and lead oxides are amphoteric. Even though if it is present in a monoxide form, okay, it can also behave like a amphoteric nature. Okay, this is a reactivity towards the oxygen. Let's see with the water. Okay, the carbon, silicon and germanium are not affected by the water, whereas the tin can decompose the steam to form dioxide and dihydrogen gas will be liberated. So if you see that tin, if it is reacting with the steam water, what does it forms? It forms a tin monoxide with the liberation of hydrogen gas. With the liberation of what? Hydrogen gas will be absorbed. So whereas the silicon and germanium, they are not affected towards the water at all. The reaction will not be absorbed. The lead is also unaffected by the water. This is due to the formation of protective oxide film on its surface. So if you take the lead oxide, if it is get attracted by the water, it forms what? A protective thin film, that is nothing but the oxide film which has been formed, which is a oxide film which has been formed. This will not allow the lead metal to not react with the water molecule. Next we have anomalous behavior of the carbon. If you see that group 14 elements, so the first one is a carbon, silicon, germanium, then tin and lead. If you see that group 14 element, the first element is a carbon, it looks different from the other rest of the element. Why the carbon will be looks different from the other rest of the elements? We'll see with the reason for that. Okay? Because of the extremely smaller size and also because of the high electronegativity and high ionization enthalpy and non-availability of d electron. Ma'am, how do you see that the non-availability of d orbitals? If you write the electronic configurations of the carbon, it is 1s2, 2s2 and 2p2. Even in the excited state, if you write, this is in the ground state, okay? This is in the ground state. If it is in excited state, if you write the electronic configuration, it shows a 4 valency. That is, it has a 4 unpaired electron. So if you see that electronic configuration in the ground state and excited state, you can clearly understand that there is no involvement of the d orbital. That is the only reason which makes a carbon, and also even though it is very smaller in size and having the high electronegativity and high ionization enthalpy, it looks different from the other rest of the elements in its group 14 members. Next we have allotrophic forms of carbon. So allotrophs means it is the existence of an element more than in one physical state. It is nothing but the existence of an element more than one in a physical state. That is known as what? Allotrophic form. And the carbon will be exists in a 2 types of allotrope. First one is a diamond, another one is a graphite. So these two are the 2 allotropes of the carbon. Which are those? Diamond and graphite. So this is the diamond structure and that is a graphite structure. We'll understand one by one first. Okay. So this is actually the structure of the diamond and it is a crystalline solid. Okay. So each carbon atom in the diamond in the crystal are bonded with a 4 other carbon atom. Thereby, it makes a giant macromolecular array. If you see that, imagine this is the carbon atom. Each carbon atom, okay, which has been bonded with the other 4 carbon atom. So, if you see that, this is a first carbon atom. Like that, each carbon atom are bounded together and it will be absorbed in the diamond structure. Each carbon atoms are bounded with the other 4 carbon atom and makes this crystalline structure. And if you see that each carbon atom which is having the 4 valency, thereby it shows the sp3 hybridized nature of the carbon. Ma'am, how do you say it is sp3 hybridized? If you write the electronic configuration of the carbon again, it is 1s2, 2s2, 2p2. If you write the shells, then you will understand that how many electrons in the ground states are available. Similarly, in the excited state also. So, if you see that in the excited state, how many electrons are become unpaired? So, in the excited state, you can clearly understand that there are 4 electrons will be become unpaired. So, it will be share its all the 4 electrons and thereby it forms a sp3 hybridized structure. So, it is s orbital and this is a p orbital. Thereby, it forms what? sp3 hybridized carbon atom and also it is tetrahedral in shape. So, each carbon atom will also bonded with the other carbon atom. Thereby, it shares all the 4 electrons and forms a tetrahedral structure with a bond angle of 109.28 degrees. Okay. And a diamond crystal or a grain of sand, it's just a one giant molecule. Such molecules are rigid, strong and have a high melting point. And each carbon atom forms a 4 covalent bonds in a very rigid giant covalent structure and makes the diamonds are very hardest with the natural substances, and diamonds is also a which makes an ideal tool for cutting. All those things, you know, the strong covalent bonds which makes the diamonds to be very hard and also with a high melting point. And if you see in the excited state, there is no electrons are available for what? Bonding, correct? No, there is no free electrons which has been available. Hence, it is a bad conductor of electricity. If you look at the structure, so understand that each carbon atom are bonded with the other 4 carbon atom. Thereby, it forms a strong covalent bond. Because of the strong covalent bond, diamonds is also very hard and also shows a high melting point, and also there is no availability of the d orbital. It is a bad conductor of electricity. Next we have graphite. This is a graphite structure. Here also the graphite is one of the allotropes of the carbon. It has a macromolecular structure. Each carbon atoms are covalently bonded with the other 4 carbon atom. So it will be like this, like a hexagonal shape. So each carbon atom are bonded with the other 4 carbon atom. Thereby it forms its strong covalent bond. Okay. Bonded with the 3 other surrounding carbon atom. So, graphite is a layered structure, and in the graphite, each carbon atoms are undergo what? sp2 hybridization. How do you say it is sp2? So, already I have told that each carbon atoms are bonded with the other 3 carbon atom. Thereby, it forms a plane-like structure, and also it can slide over one another. And if you see that electronic configuration in the excited state, if I write, it is having 4 electrons are available for bonding and hence the valency will be 4. Correct? No? But, you know, during the bonding, only one s orbital and 2 p orbitals are involved. Hence, it forms what? sp2 hybridization. Whereas the remaining 1 electrons are become unhybridized. Are become what? Unhybridized. That is why while writing, you know, we will write the one of the carbon as like this. We will write one of the electrons are become what? Unhybridized p orbital. Whereas the rest of the 3 electrons are forming a covalent bond with the other carbon atom. Thereby it forms a strong bond. Okay. And thereby it shows what? sp2 hybridization. And also each layers in the giant molecules are so bond inside the hexagonal within the each layers are so strong, but the bond between the layers are weak. This is due to the weak van der Waals force of attraction. If you see the structure, you can see that each carbon atoms are in the hexagonal plane. Each carbon atoms are in the hexagonal plane, thereby it forms a hexagonal shape. If you see that bonding inside, it is so weak because only 3 electrons are involved in a bonding, whereas the one which has become unpaired. Because of this, you know, it shows the weak bonding inside. This is due to the weak van der Waals force of attraction. Next, we have the properties of the graphite. So, where we can see the graphite? Obviously, we all know that graphites will be present in a pencil lead. Correct? No? And even though it is present in a pencil lead, it is too soft. Since the bond of each layers in the graphite are strong, more heat will be required to overcome the intermolecular forces. Thus, the graphite will shows what? Higher melting point and higher boiling point. And a weak bond between the layers, you can see that. So, this is a weak bonding between the layers I am talking. So, it is around 335. But the bonding between each carbon atom which is very stronger. Okay, bonding between the layers are very weak. This is because of the weak van der Waals force of attraction. So, they will slip one another because of the weak attraction between the layers, it will slide over one another and it will be very soft in nature. The layers are held together so loosely that they can be rubbered off or one to the paper and to leave the black mark. That is how the pencil will be work. Okay. And in the graphite, each carbon atom, the outer shell electrons are not used to form a covalent bond, hence it is delocalized, how I have shown with a carbon atom. Okay. So, this is the one which is remaining unhybridized. This electron can move along the layers from the carbon to carbon atom, hence it is a good conductor of electricity. If you see that electronic configuration, already we have understood that there are one electrons are become unpaired in the p orbital. Because of this unpaired electron, the graphites are good conductor of electricity. Next, we have fullerene. This is a small molecules of the carbon in which joint structures are closed over the two spheres of the atoms or the tubes. You can see that this is the small molecules of the carbon where each molecules are closed to form a tube-like structures or with a closed spheres of the atoms. Okay. If you see that structure of the C60 Fullerene, okay, the smallest fullerene has how many carbon atom? 60 carbon atom. They are arranged in a pentagon or hexagon footballs like structure. So, hope you observed in the football, okay. So, hope you observed in the football or in the football especially, okay. Each hexagonal shape will be observed, okay. Each hexagonal shapes will be bonded with the other hexagonal shape, or each pentagonal shape will be bonded with the other pentagonal shape and looks like a C60 Fullerene structure, and it is also known as what? Buckminster structure or Buckminster Fullerene. Okay. The C60 Fullerene consists of 26 membered ring and 12 5-membered ring. So, it is nothing but a 26 membered ring and it consists of 12 5-membered ring. Although the carbon atoms are equal in number and undergo sp2 hybridization, and each carbon atoms forms how many bonds? 3 sigma bonds with the other 3 carbon atom, remaining one which is delocalized and forms a pi bond. I will show you how does it will be looks. Okay. This is a one unhybridized p orbital. Okay. So, it forms what? 3 sigma bond, and also you can see that here also again another one carbon atom. Like this. So, it forms what? 3 sigma bond, and also this delocalizing pi orbitals can also overlap to form a pi bond. Okay. And you can see that the between the carbon and carbon single bond length will be around 143.5 picometer, and carbon-carbon double bond length will be around 136.3 picometer. This is the structure of the C60 Fullerene. Okay. So, in the next session, we are going to discuss with the most important topic, that is the oxides of the carbon. In that, we are going to discuss more about the carbon dioxide and carbon monoxide. In addition to this, we are also going to discuss with the silicates, that is nothing but silicons. Okay. By this, I conclude my session today. We'll meet you with the next session. Till that, take care. Be safe. Thank you.